Diophantine equations. Example 11.4. In how many different ways can 25 coins be comprised of nickels, dimes, and quarters be worth a total of $4? So as before, I'm letting x equal the number of nickels, y equal the number of dimes, and z equal to the number of quarters. And since I have 25 coins altogether, I know that x plus y plus z has to equal 25. And because these are now worth a total of $4, I know that 0.05x plus 0.10y plus 0.25z has to equal 4. And again, I want to clear my decimal, and then if I can, I want to reduce my equation. So I'll begin by multiplying everything through by 100. That's going to give me 5x plus 10y plus 25z equal to 400, and I can divide everything by 5 again. And if I divide every single term by 5, I end up with x plus 2y plus 5z equal to 80. And now I'm going to subtract out my first equation, x plus y plus z equal to 25. And what's going to happen is I'll eliminate my x's as before. So the x's are eliminated, and the two variables that I'm left with are the y's and the z's. 2y minus y is y, 5z minus z is 4z, and on the other side of the equation, 80 minus 25 is 55. So there's my equation in two variables. I'll solve for y again, and I have that y is equal to 55 minus 4z. Oops, I don't know why it keeps. Okay, y is equal to 55 minus 4z. And when we do our feasibility table, again, z will be the first one I pick. Plugging z into this equation, that gives me y. And then once I have z and y, I can get x. And because there are 25 coins, to get x, we'll subtract both y and z from 25. All right, dividing 4 into 55. That gives me 13.75, so I drop the decimal and I know to start with 13. Okay, plugging in 13, 55 minus 4 times 13 is 3. 25 minus 3 minus 13 is 9. So there's my first solution. Plugging in a 12, 55 minus 4 times 12 is equal to 7. And then 25 minus 7 minus 12, you could also add these together and then subtract the sum from 25. So in other words, you could say 12 plus 7 is 19, so 25 minus 19 is 6. You can get it that way also. Plugging in 11, I have 55 minus 4 times 11. That's also 11. And then 25 minus 11 minus 11, or 25 minus 22 is 3. So there's a third solution. Plugging in a 10. 55 minus 4 times 10 is 15. And then 25 minus 15 minus 10 is 0. So that is not a feasible solution because the problem stated that you had to use one of each kind. So there we are finished now, and I know if the next time I plug something else in, x is going to go negative, so we're finished. These are the three feasible solutions to that problem. All right, and again, we want to write them as ordered triples in the proper order, so we have to kind of write them the other way around. X is 9, Y is 3, Z is 13, or X is 6, Y is 7, Z is 12, and then the last one was X is 3, Y is 11, and Z is also 11.